Hi there, math campers. So welcome to our first video. This is the video that we're going to talk about simplifying expressions and solving equations. So those two things, when we talk about doing algebra, those are the two things that we're talking about. So just to be clear on how I'm using these terms, when I say an expression, I just mean a bunch of math, a set of symbols that represent some kind of number. Okay, so some examples of expressions. We could have 4x minus 1, where x is understood as a variable that could stand for any real number, but this whole thing is itself equal to another real number. Or x squared plus 3, another expression. X minus 2 squared, all expressions. To take a fancy expression that you'll see later in the fall in 200b, here's one that has 1 over sigma root 2 pi e to the negative 1/2, bunch of stuff up here, x minus mu over sigma, that whole thing squared. That is one big hairy expression. You might recognize it as the core of the normal distribution, very important in probability and statistics. We're going to get familiar with this guy, but the point is this is just a bunch of symbols here that represent a real number. Okay, so the rules of algebra, one of the most important things they do is they give us rules for rewriting these expressions in ways that hopefully make them simpler to interpret, more easy to understand, without changing the number that they represent. So if that number is important to us, we want to be able to understand it without changing what it really is. And that's what we mean by simplifying, by taking that expression and putting it into a form that makes more sense to us in the context that we're interested in, but doesn't change the number that it represents. Okay, so simplifying expressions is a big part of what we're going to be doing throughout Math Camp. Expressions often get put into equations. So what's the difference between an equation and an expression? Nothing mysterious here. Once we set expressions equal to each other, they become equations. So what makes it an equation? Oh, it has an equal sign in it. So 4x minus 1 equals 2. Once we add the equals 2, it becomes an equation. It's an equation with expressions on both sides of the equal sign, but the whole thing is an equation. Or x squared minus 2 equals 4. We could add equal signs with something else on the other side of the equal sign and make any of these into equations. When we have an expression, what we want to do is simplify. What we want to do with an equation often is solve, okay? And solving an equation means find the value of a variable that makes it true, okay? So if we're going to solve 4x minus 1 equals 2, what we want to do is we want to find the value, or sometimes there's more than one, of x that's going to make that expression true. And so the rules of algebra also give us rules for things that we can do to equations, typically doing things to both sides of an equation without changing whether it's true or not. All right, so the rules that we're going to be working with throughout Math Camp, throughout your methods classes in grad school, throughout any kind of mathematical work that you do ever in your life, tell us valid ways to simplify expressions and solve equations. So what are these rules? Let's go on. So let's first do some rules for expressions. What can we do to an expression without changing whether it's true or not? Okay. One thing we can do is we can multiply any expression by 1. Okay, so x times 1 equals x. No matter how fancy and complicated that x is, if you multiply it by 1, you don't change its value. So another thing that we can do is we can add 0. X plus 0 equals 0. add 0 to something, you don't change the real number that it represents. These things seem like you might be wondering, why would you want to do this? Well, in context, one place where we're multiplying by 1 a lot is we might multiply the top and the bottom of a fraction by the same number. Okay, so we might multiply it by 4/4, which equals 1, and that would get it to a simpler form, a form that was easier to understand. And the reason why we're allowed to do that is because 4/4 or x/x equals 1. Adding 0, when would we want to do that? Sometimes we find ourselves wanting to add something to one part of a big, long expression, probably because adding that is going to help us simplify it in some other way. It's part of a set of steps. In order to make that valid, we have to subtract it off somewhere else. Okay, and so if we add it one place and subtract it off another place, we're in effect adding 0 to the whole expression. Another thing we can do, another rule that we're allowed to use when we're simplifying expressions, is we can substitute expressions that we know to be equal. Okay, so if we just know that P1 plus P2 plus P3 equals 1, okay, like maybe we know that because they represent probabilities of the only 3 things that could happen, and so the probabilities have to sum to 1. We're going to do this a whole bunch of times in 200A in the fall. If we know that this is true, then if in some other thing that we're doing we have x times P1 plus P2 plus P3, no problem. We can just substitute the fact that that equals x times 1. And oh, isn't this lovely? Then we could use this other rule here and notice that when we're multiplying x by 1, we just get x. Okay. All right. Continuing with the rules, some of the rules actually have names. Okay, so let's go on here to rules that allow us to change the order of addition and multiplication. Okay, these are rules that you might actually remember from courses that you took sometime in your life. Okay, so commutative rules say that we can add and multiply things in whatever order we want. Commutative laws, they're sometimes called. Okay, so if we have x plus y, that's the same thing as y plus x. And if we have x times y, that is the same thing as y times x. We have associative laws, which say when we have a bunch of things that we're adding or multiplying, we can group them different ways. Okay, so if we want to add y to x and then add z, we could first add x and y and add z to that, or we can add y plus z and add x to that. Same story with multiplication. We can multiply x by y and multiply the product by z, or we can multiply y and z and multiply that by x. And then we have distributive laws. And distributive laws say that we can switch the order of addition and multiplication. So here we're thinking about addition separately and multiplication separately. What if we're doing both of them? Okay, so if we have x times y plus z, we can either do the sum first and then multiply it by x, or we can multiply x times y and multiply x times z. Okay, so the order doesn't matter here. We're saying we're distributing x over the sum y plus z. Okay, another way you could think about it here is if you have the sum x plus y times z, same story, that's the same as xz plus yz. Distributive laws are actually quite tricky. These are really valid, and you're going to use them over and over and over again with regard to adding and multiplying real numbers. very quickly, we're going to start talking about more complicated things that we do in math where you can't necessarily apply distributive laws. Okay, you can't necessarily switch the order of taking a product and a derivative, for example. You can't necessarily switch the order of squaring a random variable and taking its expected value. If this is all lingo that is unfamiliar to you, don't worry about it. I'm just kind of giving you a heads up of something that we're going to be emphasizing throughout Math Camp, and that's going to be important in 200A and the other first year classes, where you might think that you can switch the order of operations, but you can't. Okay, so enjoy the distributive laws of real numbers while you can. They really make our lives easier, and be prepared to start working with parts of math where you can't necessarily switch the order of operations that easily. Okay, so we've now gone through 4 rules for switching the order of, well, 4 rules for things we can do to expressions, including switching the order of operations, but also including multiplying by 1, adding 0, substituting those expressions. Those are all things that we do to expressions, to combinations of mathematical symbols without changing their value. 2 more rules for what we can do to equations without changing whether they are true or not. Okay, so rules 5 and 6 apply to equations, to expressions with equal signs in them. Okay, so rules still continued here, but now for equations. Rule 5 is we can add, subtract, or multiply both sides of any equation by the same number. Okay, so if we have x equals 3x plus 5, and we want to multiply that by 2, we can do that. Okay, we just multiplied every part of that equation by 2. 2x equals 6x plus 10. If the thing that we started with was true, the thing that we get to is still true. And the final rule is, you might say, add, subtract, multiply. What about divide? It's almost the same for divide, but not quite. We can divide both sides of any equation by any number. So far, so good, except 0. No dividing by 0. Okay, small exception, lots of the time doesn't matter. It is something we always have to keep in mind, both as a fact. Okay, we're going to be trying to draw your attention to places where we might accidentally be dividing by 0 without realizing it's something we have to be aware of. The fact that we cannot divide anything by 0. If you try to divide a number into 0 parts, it doesn't make sense. It's not part of math. Please don't do it. And don't do it even by accident. Another comment about this final rule, about this exception that you can't divide by 0, is get used to more of this. 0 is an amazing number, like kind of the invention of 0 made mathematics like much more powerful than it would have been without that, but it is also tricky. It's special in lots of ways, and this is just the first way that we're seeing 0 be special. Okay, so those are our rules. Like, you can now do almost all the algebra you want with these rules. They're very, very empowering. And I encourage you right after watching this video to check out the quiz, see if you can apply the rules on some fairly simple problems there. Then go on to the practice problems, and some of them get increasingly more complicated, but they're going to give you practice with applying these rules. As you do that, 2 things to to be prepared for, not to be scared of, but just to be ready for two problems that we have in applying these nice, simple rules. First problem is sometimes you just don't know what to do. Okay, sometimes you find yourself looking at an expression and it's such a mess you just don't even know where to begin. Sometimes you start to do something you think is going to make the expression simpler and it ends up making it more complicated. Dang. All I can say about this is don't be freaked out. And please don't think it's just you. This is just part of doing algebra. Things don't always work out the first time. Sometimes you don't have ideas. As you get more experience, you'll get better at it and you'll learn to roll with the minor defeats. Second problem with the rules, and it's actually a pretty big one, is like sometimes we do them wrong. We make all sorts of mistakes doing this. And I would say a good thing about math is because we're all trying to follow the same rules, we can all be in agreement about when they're not being followed. You will make mistakes. Everybody will make mistakes. People will do things that involve dividing by zero. They'll make logical errors. This is part of math. And again, when you make a mistake, don't think, I knew I wasn't good at this stuff. Just think, oh, here it is. Here's me doing something that's kind of hard, not getting it right the first thing, but yay me, I caught my mistake. And that's the way to manage this problem of making mistakes when you're doing algebra, is to recognize that the mistakes that you find, that's a victory, finding that mistake and understanding the rules, going through the steps in algebra, maybe more slowly and systematically and self-consciously than you're used to, is going to help you get better at catching your mistakes, at helping other people find their mistakes, and doing them more smoothly. So as you're doing the practice problems, I'd encourage you to go slowly. As you're working each step, ask yourself, okay, what am I doing here? Am I multiplying by 1? Am I multiplying both sides of the equation by the same number? Am I using a distributive law? And ask yourself what you're doing. You will not be doing algebra with that level of self-consciousness throughout the class. You'll get quicker at it. But early on, if you've been away from algebra for a while, being very slow and deliberate at the beginning will help you go faster in the end. So before you go to the quiz, there's a second video with a couple of examples. You might want to check that out, and then be sure that you work the quiz and do the practice problems. So have fun.